Hi guys, welcome to today's tutorial. Today we'll be looking at a topic called surds. Alright, now what are surds? Surds are irrational numbers, as simple as that. Now, why do we call them irrational numbers? Now, those irrational numbers that they are following decimal points have no ending. Alright, examples. Okay, there are radicals. The radicals in them cannot be completely removed when simplified. Okay, examples are root 2, root 5, root 7, 3 root 5, etc. There are so many of them. Now, why do we study surds? Now, the essence of studying surds is to enable us know how to eliminate them in our equations. Okay, now there are a few rules of surds which we are going to look at. All right, we have the addition of surds. Now, before we can add any two surds, now two surds must be added only when their roots are of same value. Okay, for example, if we have 2 root 2 plus 3 root 2, that is only when we can add both surds, when their roots are the same. Okay, but if their roots are not the same, they can't be added together. Alright, I repeat, if their roots are not the same, they can't be added together. But once their roots are same, then we can add them together. We'll see few examples as we progress in our class today. Now, our second rule talks about a root x minus b root x. That means we'll collect our terms together, a minus b, then root x. Now, since they are in same root, it's like factorizing. Alright, what's common here? What's common here? Root x. We keep it out. Then a minus b will find their difference. Likewise for the addition. Alright, now looking at root x raised to power n, okay, it's just like, let's say for example we have third cube root of x raised to power 3. So this will cancel our cube root. That's why we have it as x. Okay, so when the number to which we have root raised is sent to the power to which the x is raised, then it gives us the value which we have in x in our box there. Now, the fourth one says x n root nx times root ny. Now, since they are same root, okay, that means we can multiply our terms inside as x times y root of that number. Okay, like I said earlier on, we'll look at examples on each and every of this as we progress. Okay, now the fifth one talks about x over y root sign. Okay, since the root sign we know in maths is shareable, as it's shareable, we can also bring them together. Now, since they're same nth root, so it becomes the nth root of x divided by y. Alright? Likewise, for our multiplication, now here, for the multiplication, we have the nth root of x times the nth root of y. So this becomes n times y. Okay? Our roots will multiply n times y to the root of what? X raised to power n times y raised to power n. Now you can see the interchange in here. We have x raised to power m and y raised to power n. So there's an interchange in there. Same thing with a division. There's an interchange of their root signs. Okay. Now this becomes mn divided by x raised to power m divided by y raised to power n. Okay, now to our eighth row, we have it as root m, okay, nth root, okay, and nth root of x in 8 becomes n times n root x. Okay, now when we have same root sign, okay, root x times root x or root 2 times root 2 gives us 2. Why? 2 times 2 gives us 4. So that means the root of any number multiplying itself twice gives that number. Alright, now let's look at examples on each and every of these rules. We'll take them one at a time and look at examples in each and every one of them. So stick with us as we go through our examples in each and every one, explaining them more explicitly to you. Alright, now looking at few examples here from question 1, if we have 3 root 2 plus 5 root 2. Now, since they're having same root signs, what we are going to do is 3 plus 5, alright, root x. Okay, so this gives us 3 plus 5, so root x here will be 2. 3 plus 5 will give us 8 root 2. As simple as that. So whenever your root signs are same, you can add up the numbers out. Likewise for the subtraction, when you have 5 root 3 minus 2 root 3, this becomes 5 minus 2 root 3, which gives us 3 root 3. Okay, now for this, if we have it as a third root, cube root of 2 raised to the power 3, this is something as, remember that our root sign, our cube root sign, is something as 2 raised to the power 1 over 3 times 3 over 1. So that is why we have it as 2. Okay? Now, for the fourth one, we have it as, if we have root x, okay, root 2 times root 4, okay, root 2 times root 4, this will give us root, okay, let's do cube root of 2 times cube root of 4 would give us a cube root of 2 times 4, which is cube root of 8, and cube root of 8 will give us 2, okay. Now, to the fifth one, now looking at our fifth one, if we have something here, if we have this as a cube root, okay, let's do root of root 8 divided by root 8 divided by root 2, okay, we can rewrite this to be root 8 over 2, which gives us root 4, alright, and root 4 would give us 2. Looking at our next question here, we have it as n root x times n root y, okay, now, which gives us a n root x raised to the power m, y raised to the power n. Okay, now in this case, what this simply means is that if we have a third cube root of x times square root of cube root of 2, okay, cube root of, let's say cube root of 8 times square root of 9, this will give us 3 times 2, okay, raised to the power 8 raised to the power 2 times 9 raised to the power 3, okay. So this will give us as, this we are having as a sixth root of 64 times 7 to 9, okay. So in that way, we can simplify it out. So 729 times 64. So this gives us the sixth root of 46656. So finding the sixth root would give us 6. The sixth root of this would give us 6. Alright, now to question 7, okay, to our example 7, here we have it as n root x over n root y, m root y, okay. This is something as m n root x xn all over m n y root power n. Okay, now looking at figures we can have here, okay, all over square root of 2. So this gives us 2 times 3 root 2 times 3 root 8 raised power 2 all over 2 raised power 3. Okay, so having this here now, we cannot say this to be 6 root 8 raised power 2 will give us 64 all over 2 raised power 3 will give us 8. So this becomes the sixth root of 8. Okay, and the sixth root of 8 will give us what? Sixth root of 8 will give us 1.4. So this becomes 1.4, or we can leave it as sixth root of 8. Now to our question 8, example 8, where we have it as n root x, okay, will give us n root x. So this we have as our cube root of our square root of 8. This gives us, okay, this gives us 3 times 2, sixth root of 8. Okay, now to the ninth one there we have it as root 3 times root 3. Root 3 times root 3 will give us root 3 times 3, which gives us root 9. So root 9 will give us 3. So that's how we have those examples. So I believe with this, as we get into more questions, you should be able to know how to apply each and every of those law. So stick with us as we go into more detailed questions on applications of this law. If you haven't subscribed, subscribe and share this link with your friends. Alright guys, let's look at these two examples. Now, the first one says, simplify 3 cube root of root 729 x raised to power 6. Now, in doing this, okay, we can first of all find root of 729, or we can apply a law that says, since this is root, okay, remember our law that says if we have n x, we have it as n root x. Okay, so we can apply that law here. So this can be 3 times 2 root 729 x raised to power 6. Okay, so now we can now find the sixth root of what number are we going to multiply 3 times, 6 times to give us 729? Is that possible? Yes. So multiplying our 3 6 times, so this becomes 6 root of 729 x raised to the power 6. So we can now have this as 3 raised to the power 3x. Now how do we eliminate this 6? This is root 729 is giving us 6th root of root 729 is giving us 3. Okay, and the 6th root of x raised to the power 6 is like 6 times 1 over 6. So this cancels out, leaving us with x. So our final answer will be 3x. Now, to the second question, same thing, it says simplify 6a times root 576 e raised to the power 6, okay, or root. Now, still applying our same law here, okay, still applying our same law here, we have this as root 6a times root what? 576 e raised to the power 6. Okay, now since this is 2, okay, we can have this as root 6a times 4, 2 times 2, 4, root 576 e raised to the power 6. Okay, so we can now break this down, and looking at our root of 576, root 576 will give us 24. Okay, let's still leave it this way. So our root 576 will give us 24. This gives us 24 e raised to the power 6. Okay. Okay, breaking down this, okay, let's see. If we have root 576 times root e raised to the power 6, this will give us 24 times e raised to the power 6 times 1 over 2, which gives us 24 e raised to the power 3. So this should be e raised to the power 3. Okay, so having that as 24 e raised to the power 3 here. Okay, now we can now open up, multiply through. So this will give us 24 times 6. This will give us root 6a times 24 e raised to the power 3, which will now give us 24 times 6 will give us 144, okay, times 3a times 1 will give us e raised to the power 4. Okay, now looking for the root of 144, root 144 will give us plus or minus 12. Now, e raised to the power 4 times 1 over 2 will give us e raised to the power 2. So that leaves us our answer with plus or minus 12a raised to the power 2. Alright, we are going to look at next. What we are looking at next will be simplification of surds. Okay, how to simplify surds. Okay, now looking at simplification of surds. Now, the basic thing to understand in simplification of surds, or what to look out for when simplifying any form of surd, is to check out in your radicals, do they have any perfect square? Now, once you can identify the perfect square, you are one step away from simplifying that surds. Okay, you are one step away from simplifying your surd. Now, let's look at our first example that says root 12. Now, if we look at the multiples of 12, what are the multiples of 12? We have 1 and 12, we have 2 and 6, we have 3 and 4 as multiples of 12. Now, among all these numbers, okay, looking at 12, we have 1 and 6, 1 and 12, 2 and 6, 3 and 4. Now, among all these factors of 12, which of them has a perfect square? This. Right? Now, our 4 is our perfect square, where we have 2 times 2 to give us 4. Now, in this, we are going to use 4 times 3 to simplify our 12. So this becomes root 4 times 3. Okay? Which one shared becomes root 4 times root 3 to give us root 4 will give us 2 root 3. Okay, that's for 12. Now, looking at 72 also, 1 and 72, we have 2 and 36, 3 and 24, 4 and 18, 6 and 12. Alright, now in base we have 2 that contains what? Perfect squares. Okay, we can use this, we can use this. Alright, but if funny enough, if we use any of them, we will still arrive at same answer. But for this, we still have to break it down to another perfect square to get our answer. Alright, we'll look at both examples. Now, using our 2 times 36, okay, this becomes root 36 times root 2. And root 36 is what? 6. 6 root 2. Okay, now let's look at using 18 and 4. If we use root 18 times 4, this will give us what? Root 18 will become 9 times 2, still breaking it down, times root 4. And root 4 we know is 2, and this times root 9 is 3 times root 2. Okay, so 3 times 2 will give us 6 root 2, which brings us back to same answer. Alright, that's that for that. Our next question is second on about 300. Now root 300, we are going to use root 3 times root 100. 3 times 100 will give us 300. So this becomes root 100 times root 3, which is root 100 is 10 root 3. Looking at our root 54, for 54, we have it as 3 times 18, okay, root 3 times 18, but 18 can still be broken down to 9 times 2, okay, so we can now break this down to what? 9 times 2, which is 9 times 6, okay, so this, we are having it as what? Root 3 root 6. Okay, next we have our 108. This becomes root 9 times root 12, but 12 can still be broken down to give us root 9 times root 4 times root 3. Okay, so root 9 will be 3, root 4 will be 2 times root 3. So this will be left as our answer will become 6 root 3. So our answer for here will be 6 root 3. So talking about 180, we have it as 180 we have it as root 9 times 20, which can be broken down as root 9 times root 4 times 5, which gives us 20. Okay, this we can still break down as 3 root Root 9 is 3, root 4 is 2 times root 5. So this gives us 6 root 5. Alright, now, so like I said earlier, in order to simplify your radicals, you are simply going to look for the perfect squares in each of your radicals. And once you're able to identify the perfect squares, and then you can simply go ahead to simplify your radicals. Alright guys, we've come to the end of today's class. If there are any questions or comments, put them down in the comment section below. And in our next class, we'll be looking at the operations, addition, subtraction, multiplication and division of our radical numbers or surds. So ensure you do not miss that class. If you haven't subscribed or liked our channel, please endeavor to do so as it helps us grow. Also share this link with your friends and for colleagues to enjoy this lecture also with you. Thank you. See you in our next class.